about how to find the opportunity costs when you have production possibilities. Here we have three different producers, kappa, lambda, and mu. These are named after Greek letters. And kappa can produce two goods, either 300 A's or 600 B's. And often the way the production possibilities are listed is that you are given the two extremes. That is, if kappa makes nothing but A, kappa could make 300 A's. If kappa makes nothing but B, kappa could make 600 B's. Now, kappa might be a person, it might be a factory, it might be a country. We don't care about that for our purposes. It's just we know that the two extremes are if they make nothing but A, they can make 300 A. If they make nothing but B, they can make 600 B. What's the cost of making 1A if kappa makes it? Well, that kind of question starts with the assumption that we know that the opportunity cost of making 300 A's, if kappa makes it, is 600 B's. Because the way this is set up, we're assuming that if the extreme is done, that you do nothing but make A, kappa makes nothing but A, then they're giving up making the 600B. Now, we are allowing for the fact that perhaps if you spent half of kappa's time or effort or whatever it is on making A, you can make half of this number of A. In other words, you could maybe make 150 A's and then have half the time left over to make the rest of the B's that are possible, which would be 300 B's. Half of this number of A's and half this number of B's, those would go together. But we're here looking at the two extremes of 300 A's or 600 B's, and we're going to use that to figure out the cost. Because while we know that 300 A's cost 600 B, imagine a recipe where you had a recipe that would make 300 of something, in this case A's, and we don't want to make that many. All we want is 1A. Well, then really what we're doing is cutting the margin. That is, we're cutting the additional A's that we're going to get down from 300 to a smaller number. Now, how we do that, how you would divide a recipe, for example, to make it a smaller recipe to get what you wanted to make, not the whole thing, you would divide. But again, the reason why we're dividing is to make the margin smaller. We're going to get, kappa's going to get 300 A's when they make nothing but A's. We don't want that many, we only want 1A. If you take 300 A's divided by 300 A's, you get 1A. So what that means is, how do you find out what that costs? Well, if you're dividing this side of the little kind of cost equation, if you will, kind of think of like this is an equation where cost is the standing in for the equal sign. If you're dividing this side of the equation by 300, you also have to divide this side of the equation by 300. And so you would get, I hope you see, if 300 A's divided by 300 is 1A, 600 B's divided by 300 gives you 2 B's. And so the cost of 1A, if kappa makes it, is 2 B's. So that's the cost of making 1A. What about the cost of making 1B? Well, if you want to make 1B, you've got to remember again, you could make 600 B's, and that would cost you the 300 A's that you could have had instead. So if we want to find out what the cost is of 1B, kind of do the same math. You take this and you say, well, that recipe is too big, or that margin is too big. To get the margin to the size I want it, I'd have to divide by 600. And that would give me 1B. But if I'm dividing that by 600, I also have to divide this side by 600. And so 600 B's divided by 600 would give me the 1B I want. I'm bringing the recipe down to the size I want it. But 300 A's divided by 600 would give me a half of an A. And of course, 1/2 of an A is also 0.5. So if you did a calculation on a calculator, that's what you'd get. So we now have the cost of making 1A from the production possibilities of kappa. And we also have the cost of making 1B from the production possibilities of kappa. Now, if we had another resource, we'll call that lambda. Again, lambda could be a person, lambda could be a factory, it could be a land, it could be a country. They could make 300 A's in lambda if they did nothing but make A's. They could also make 800 B's if they did nothing but make B's in lambda, and presumably they could also do things in between where you're kind of dividing up their time between A's and B's, and you could get some combination. But what we're interested in is, what is the cost of lambda making 1A? Well, the cost of lambda making 1A, we don't know. But we do know that 200 A's cost 800 B's. And so using the same kind of reasoning and logic and math that we used before, if we don't want 200 A's, we want to make that margin smaller, we divide that by 200, but then also we have to divide the number of B's that you're having to give out by 200. And so you get 200 A's divided by 200 is going to give you 1A. 800 B's divided by 200 is going to give you 4 B's. And so we end up with the fact that in lambda, or made by lambda, the cost of 1A is going to be 4 B's. If we instead wanted to find out what's the cost of making 1B by lambda, well, lambda could make 800 B's if lambda did nothing but make B, but that would cost lambda 200 A's. If we only want 1B, then we got to divide this 800 by 800 to get the 1B. We also take the 200 A's and divide that by 800 to make sure that there's symmetry on both sides of that cost equation, if you will. And so 800 divided by 800 is going to give us 1B. 200 divided by 800 is going to give us 1/4 of an A. 1/4 of an A, of course, is 0.25 of an A. We have another producer named mu. Again, that's the Greek letter that comes after lambda. And 500 A's is how much they could make in mu if they did nothing but make A. 1500 B's is what they could make in mu if they did nothing but make B's. And so if we want to know what's the cost of mu making 1A, well, the cost is, we don't know for 1A, but we know 500 A's cost us 1500 B's if mu makes them. And so we divide this by 500 to get the recipe down to size. We divide this by 500 to get the recipe down to the appropriate size. And so what we end up with is 500 divided by 500 is 1A. 1500 divided by 500 is 3 B's. And so we've got that the cost of mu making 1A is going to be 3 B's. We also can find out the cost of making 1B, of course. We know that those 1500 B's would cost us 500 A's. So if 1500 B's cost 500 A's, how much does 1B cost? Well, you divide this by 1500 to get that recipe down to size, to reduce the size of the margin down to 1 instead of 1500. And we're going to divide this side by 1500 as well. And so if you take 1500 B's divided by 1500, you get 1B. If you take 500 A's divided by 1500, you get 1/3 of an A. 1/3 of an A, of course, is also 0.33, and actually it's 0.33333, and it keeps on going, but we'll just round it off to 0.33. And so now, from the production possibilities, even though the numbers of stuff that we're going to make, according to the production possibilities, is much bigger than just 1A or 1B, we can find the cost in each of these three producers, by each of these three producers, kappa, lambda, and mu. We can find what the cost is of making 1A by each of these producers and what the cost is of making 1B by each of these producers. And so that's how you use the production possibilities to find marginal